Hi everyone. In this video, we're going to talk about Fastbin double-free vulnerabilities. Recall that in previous weeks, we have talked about T-cache beans used after free vulnerability. We mentioned that a chunk can be freed for twice, and both of them can be inside the T-cache bin. So a chunk can point to itself or point to other chunks and then point back to itself, creating a loop. Turns out that in Fastbin, a free chunk cannot point to itself. However, the chunk can still point to other chunks, and then the other chunks is going to point back to the free pointer. In this way, we can still take advantage of a double-free vulnerability, creating a loop inside the Fastbin, and then take advantage of that vulnerability to arbitrarily control the execution of the program. In this video, we're going to walk through a Fastbin double-free vulnerabilities. Suppose that we already filled T-cache bin, and additionally, we have had 3 chunks in Fastbin. In Fastbin, the 2 blue chunks are identical. So we have freed a chunk, which is currently denoted in blue. We have freed that chunk for twice, and both of them are in Fastbin. To trigger the vulnerability, we will firstly empty T-cache bins by malloc. After that, T-cache bin will be empty, and there are 3 chunks in Fastbin. In the next, we're going to use malloc to get the blue chunk returned to the malloc. And the Fastbin works as follows. As we discussed in the Fastbins used after free vulnerability, we know that when the malloc is called, in this case, the blue chunk will be returned for the malloc. And then glibc will refill T-cache bin with Fastbin chunks. It will scan over the chunks in Fastbin and then move to the next chunk, and then also move that chunk from Fastbin to a T-cache bin. Actually, this is composed of 2 small steps. The first one is to move the pointer from the current chunk to the next one. And then the next one is to move the black chunk from Fastbin to T-cache bin. And then this process will repeat until there's no more chunks need to move from Fastbin to T-cache bin or T-cache bin is full. And to be clear, let me write down this process here in the slide. So the first small step for malloc is that we're going to move the pointer to the next chunk of Fastbin. And then the second is to move the chunk from Fastbin to T-cache bin. And then similarly, we're going to repeat this process for the blue chunk. So first, we're going to move the cursor to the next. You might think that there is no more chunk over here, but however, when glibc look at this blue chunk, let's go back to the previous one. So actually, the FD pointer inside the blue chunk will point to the black one. So glibc will consider that there is one more chunk, which I show here in dotted line, and then the cursor will move to that illusional one. And then we're going to move the blue one to T-cache bin. And remember that for T-cache bin list, it's going to be last in, first out. So when the blue chunk moves to T-cache bin, blue chunk will be ahead of the original black chunk. And then following the 2 steps again, the cursor will move first, but then at this point, because the black chunk has had the data field of 0, The cursor will not keep moving. And then this chunk will be also considered to be a part from Fastbin, and then it's going to move from Fastbin again to Tcachebin. So very interestingly, if you finish the entire process of malloc, you will find that actually there is a repetitive black chunk in Tcachebin again now, with the blue chunk in the middle. So in this way, we actually managed to free the black chunk for twice. This is another possible vulnerability from Tcachebin that we can use. We can just repeat the process for Tcachebin's double free. In this video, I'm not going to repeat that process. But for now, let's just keep using the blue chunk that we have got from malloc. So the next, what we could do is to use that malloc and then change the chunk information, edit it to have the blue chunk point to another fake chunk. After that, all we need to do is to malloc for 3 times. So the first time is gonna return us this chunk, the black one. The second time we're gonna get the blue one. And then the third time we're gonna get the victim, the fake chunk. And from there, we can edit the fake chunk, have the victim part overridden by an arbitrary value, and then we can just overwrite a global offset table. We can also just overwrite malloc to the winning function or a gadget that we want to jump to. Now let's program the attack together. I'm going to reuse the same attack template that we had before. And in the template, we have written everything but the lunge attack, the key part of the attack. And similar as what we did before, let's first draft the outline of the attack. So the first part for us is to prepare for the layout of Tcachebin and Fastbin. So we need to fill in Tcachebin, fill that with 7 chunks. And as well, Fastbin with 3 chunks. Also here, we want to make sure that in Fastbin, we have 2 identical chunks being freed for twice. Based on the layout, then we're gonna first empty Tcachebins. After that, we need to do malloc. And then we'll be able to get the chunk that has been fragmentized. I'm going to call it the vulnerable chunk. After that, if you still remember, we will have this layout in Tcachebin. And then the next, we need to edit the chunk that we return from the second step of malloc and have the chunk linked to a fake chunk. And the fake chunk is going to contain the victim memory. And then the fourth step, we're going to malloc for 3 times. And the third time, we're going to get the fake chunk. After that, similar to what we did before for other use after free and double free vulnerabilities, we're going to overwrite the content of fake chunk to the target, or say malicious function. And then next, which is also the final one, we're going to trigger the vulnerability. All right. Now let's start to fill all those necessary steps. So in the first step, we need to get 7 chunks in Tcashbin and 3 chunks in Fastbin. So we need to have 10 bins, 10 chunks in total. Actually, let me correct that. We need to have 9 chunks in total when we malloc it, because in Fastbin, there are 2 chunks that are identical. So we need 7 chunks from Tcashbin and 2 unique chunks from Fastbin. So there's 9 in total. And then we're gonna first free all those chunks to Tcashbin. And then we're gonna free the chunk number 7, free the chunk number 8, and again, chunk number 7. And here, if you look at the slides, we should be able to know that right now we're at the stage, and the blue chunk is chunk number 7. The black chunk in Fastbin is chunk number 8. Then the next, we're gonna empty Tcashbins, and we're gonna empty Tcashbins using malloc. Because we need to add those chunks in the future, now let's just track the index. So at the beginning of the malloc, we already have chunks with the index of 0 to 8. There are 9 chunks that we have malloced in the first statement. And then from here, we're going to malloc for 7 more chunks again. So that's going to be index from 9 to 15. Then the next step is that we're going to malloc again to get the vulnerable chunk. So we're going to do malloc again. And this return chunk should be with index 16. And in the third step, we're going to link that by added. So we need to add the chunk with the size, with the index of 16. And then the content should be the victim address. And the reason why here we put the victim address instead of the victim address minus hex 10 is because at this point, when we do, like after we do the second step, everything is in Tcashbin. So here, when we do added again, we need to change this linking. It's going to follow the rule in Tcashbin, which is to have the forward pointer point to the data part of a chunk. So here we should have the victim place. And I'm going to just use the got table again. And I'm going to use the malloc also. But you can also just change that to other content or use malloc hook. Okay, and then the next is to malloc for 3 times. And then the third time, we're going to get to the fig chunk again. So we do 3 times, 1, 2, 3. All right. And then here, let's track the index. This is 17. This is 18. And this is 19, which is also victim. And if we look at the slides, right now we're at this stage already. We already got to the victim chunk. So next, we need to overwrite the victim chunk. And specifically, we need to overwrite the victim memory with the malicious function. So we need to edit the chunk with the index of 19, overwrite that to some value that we want, which can be a winning function. After that, we're going to trigger the vulnerability. And you can just use interactive to interact with the server. And then you're going to, in the interaction, you're going to use a malloc so that it will go to the function of win. Now let's run the program. And let me just exit it. And we can get the winning function. We can get the message, you win. In summary, for Fastbin double-free vulnerability, you need to make sure that you can create a loop in a Fastbin, and also this loop does not only contain the identical chunk, but also include the other chunk. So basically, you need another chunk to be in the middle of the entire loop. After you create that, when you do malloc, especially the malloc with the refilling process from Fastbin to Tcachebin, you want to pay attention and make sure that the order is correct. After we get this order correct, the rest is pretty straightforward. You can just do the similar things as what you did for a Tcachebin double free, and that will lead you to the winning function or a gadget that you overwrite your victim memory.